Wisdom Mathematics tutorial on complex numbers. We have a question which says convert z equal to 3 plus 4i to polar form. In our previous video we talked about different forms of a complex number, and we said that a complex number can be in rectangular form, which we also know as general form, in which case this complex number can be written as x plus iy. Then it can also be in polar form, which is written as z equal to r into cos theta plus I sin theta. And in the third form, we have what you call Euler form, or you also call it exponential form of a complex number, in which case z is equal to r exponential I theta. In this case, the r here is the modulus of the complex number, while the theta is known as the argument of the complex number. Now in the question we have to convert, the complex number initially is in rectangular form, which when compared to this rectangular form, we're going to have that 3 is equivalent to x and 4 is equivalent to y. Then this I is talking about the imaginary part of the complex number, because this particular part where we have x is the real part, while this part is the imaginary part. So the value of this y is equivalent to this form. Now with this, we can convert this complex number from rectangular form to polar form. Now the first thing to do is to know the form of complex number referred to as a polar form. And polar form, as we have already known, is that z is equal to r into cos theta plus I sin theta. The same value of theta that we have here will also be the same value as we have on this part. So for us to convert this complex number to this form, we have two things to obtain. First of all, we obtain the value of this r and also the value of this theta. For us to do that, r there is known as the modulus of the complex number z, and this is obtained as the root of x squared plus y squared. And for us to get this, we simply have to obtain the values of x and y. Now from the rectangular form that we have, 3 plus 4i, we can say that our x is equal to 3 and y is equal to 4. Now for us to get the modulus of this complex number, we have to substitute these values into x and y to get the modulus. For us to do that, we have that modulus is equal to the square root of 3 squared plus 4 squared, which is going to give us 9 plus 16. Then we're going to have that 9 plus 16 is going to give us 25, and the square root of 25 is 5. Now the modulus of this complex number is equal to 5. Now after that, we're going to get the argument, and the argument is given as argument of z, which is theta, is equal to the tan inverse of y all over x. We have known the values of y and x as 4 and 3. So we now say that theta is equal to tan inverse of 4 all over 3. And tan inverse of 4 all over 3 is going to give us 53.1, which when we approximate to nearest whole number, we are going to have that argument is equal to 53 degrees. Then at this point, we are going to substitute this 53 for theta into this, and the 5 we have for modulus into this. Once we do that, we have converted the complex number to polar form. So we now have that since our modulus is equal to 5 and our argument is equal to 53 degrees, we can say that the complex number in polar form is now going to be 5 into cos 53 plus I sine 53.